And welcome everybody once again to the Daily Space Weather. I'm your host Dan, aka smAsho. Today we'll be talking about an increase in the solar radio flux, showing some tsunami footage, talking aftershocks, and showing, as always, lots of imagery of the sun. The sunspots have degraded. You can see those two bright spots down there in this composite image. This is three wavelengths, 211, 193, and 171 angstroms. That's 171 angstroms. Here's just 171 angstroms and a colorized magnetogram. Sunspot 2806 looking like it's a little bit stronger than 2807. And we'll classify those toward the end of the video. Here's a HelioViewer movie. This one's got the full disk in 304 angstroms. Not a lot of changes going on in those sunspots in the past 24 hours, but I think they've degraded. Here's another wavelength, 94 angstroms. And we've gone from ionized helium to ionized iron. And how about one more? Here's 193 angstroms. And we are expecting a coronal hole wind stream, a high-speed coronal hole wind stream, which is expected to trigger a minor geomagnetic storm from this coronal hole late today and early tomorrow on late March 5th, early March 6th. And we've got some more data to cover here. How about a diagram of the solar system? Are you interested in where planets are located? Well, here they are. And you can see Venus swinging around to the opposite side of the sun there, and Mercury catching up to do the same. We've got a gibbous waning moon. And there's where things will be in a week, right around the new moon. Leave us a comment. Let us know what your favorite phase is. Mine is new moon. And our regular viewers would know why. I won't divulge in this video. Perhaps in the comments. If you're up before dawn, you may see the moon and you may see Saturn rising ahead of the sun. One of the brighter objects you'll see, it's like number 5 or something like that. Let's see. The sun, the moon, Venus, Jupiter. It's about the 6th brightest object there, Saturn, following Mars. And Mars and Jupiter sometimes switch places for the brightest object visible in the sky. Anyway, that's a star chart. The radio flux has come up to 81. So wasn't really expecting that as we saw those sunspots degrade. Maybe one of them grew. So again, stay tuned at the end of the video. We will do some analysis of sunspot 2806 especially. Again, radio flux, the 10.7 centimeter variety, which emanates from the upper chromosphere and the lower corona at 81 solar flux units. And yes, the sun is the strongest radio source in the sky. If you know the second strongest radio source in the sky, leave us a comment and let us know. I'll give you a hint. It's a distant galaxy. Here's the radio flux, this black line here in context. That's a 1-year chart, and you can find that yourself at solon.info. Notice how proportional to sunspot number, which is the red line, the radio flux is. Here are our warnings, and you can see here late today on the 5th and early tomorrow on the 6th, a G1 geomagnetic storm forecasted there, expecting a KP of 6 as per the NOAA forecast. No argument there. And let's see what volcanoes are erupting before we get into seismicity. Indeed, Klyuchevskoy on the Kamchatka Peninsula is exploding. It's producing a 16,000-foot ash plume. Suwanosejima exploded as well, 5,000-foot ash plume over it. Mount Raung in East Java, it wouldn't be wrong to say Raung, has produced a 14,000-foot ash plume, flight level 140. Here's a new one we've never covered on the channel before. Veniaminoff on the Alaskan Peninsula produced a 10,000-foot ash plume there during an eruption yesterday around 5:13 local time. And we see fresh ash deposits visible at the summit generated by the explosion. Pacaya has dissipated its ash down there in Guatemala. Fuego, also in Guatemala, still exploding, 14,000-foot ash plume there. Sabancaya exploding as well, 22,000-foot ash plume emanating from its caldera. And Sabancaya, while we're unable to detect, please do not square dance around the caldera down there in Peru at Sabancaya. It could be unhealthful. So we saw some massive earthquakes yesterday, 2 7+ magnitudes and an 8+ magnitude quake northeast of New Zealand in the Kermadec Rift Zone. So there's a giant trench there northeast of New Zealand, which has actually got 2 names. It's just 2 names for one trench. It's called the Tongan and Kermadec Trench. And here is some footage of that tsunami. So this one is from 7 News Australia. And you can see this small tsunami rolling in here. Not sure the size of that. Probably less than 1 meter. Maybe like 1 foot was sort of the low ball estimate of the size of that tsunami. Not many reports coming in, so any tsunamis that were generated by that 8+ magnitude quake there in the Kermadec Rift Zone apparently not really panning out. So I didn't search too exhaustively. And if you're wondering who that is Wilhelmina Shrimpington. Wilhelmina Shrimpton. What a name. Again, there's the footage of that tsunami there. And there were a bunch of evacuations and so on at New Zealand from this quake. So here's this quake. And here you can see the this is the Tongan portion of the trench. And this is the Kermadec Trench. And that earthquake happened right in there, as well as a couple 7 magnitude quakes. And that was an 8.1 magnitude quake, which occurred at 1928 Universal Time. So around 7:30 Universal Time yesterday is when that 8.1 magnitude quake happened. And we're going to quickly scroll up the list here, as it's a giant list of aftershocks and foreshocks. So first we saw a 7.3, and some tsunami watches were issued from that. And right after they were lifted, we saw that 8.1. Small deep quake there south of the Kamchatka Peninsula there. I would note also this shallow quake here at 800 meters above sea level. That one nearly directly below the caldera of Mauna Loa. So there's the main caldera right here of Mauna Loa. And you can see how nearly perfectly below that caldera that 800 meter above sea level quake was. An interestingly deep quake indeed, in that its depth is negative 0.8 kilometers. So we're just going to let this scroll up here. We don't want the video to be too long, talking about who knows how many earthquakes. There was a 5.6 at Greece also, which barely even makes the news as a result of those 7s and that 8 magnitude quake at north of New Zealand there. And since there are so many aftershocks, we're scrolling kind of quickly today. If there's anything we didn't cover, just leave it in the comments. We do read all comments on the channel. So countless quakes there in the 5 magnitude range. Mostly aftershocks from those 7s and that 8 magnitude quake. Now this Smash stream was brought to you from twitch.tv/smAsho. So we don't always stream live to Twitch, but it's such a great mobile platform that it's just as good as recording a video. And they've got a great mobile app as well. Perhaps consider picking that up. Twitch.tv/smAsho is the URL. And if you're on YouTube, don't forget to press like and subscribe over there on YouTube. Tell your friends, foes, science noobs, and science pros about the channel. Lots of big things coming from the channel. No more on that. Our patrons are already aware of what I'm talking about. Thanks to our YouTube subscribers. We're also on BitChute. There is exclusive content there as well. And let's do a short cosmology segment. Today we're going to pick a random number between 1 and 1031 because that coincides with some specific X-ray source at the Neil Gorell's Swift Bat X-ray Observatory. So let's see what random quantum number we get today. Rolling the dice, or the die, I should say. It's a 1031-sided die, and today's random quantum number is 380. Let's see what that object might be. There is value in looking at random objects, by the way, as there's a lot of stuff to learn when it comes to cosmology, especially if you have no idea what you're talking about. So here's an X-ray source. This is probably Milky Way galaxy-based. It's J11321-5311. That's J11321-5311. An X-ray source. Not sure what it is. Probably a star. Just putting it out there, folks. But in any case, some sort of a source of radiation. Maybe it's an alien spacecraft. Maybe it's Darth Vader's butthole. Who knows? But there is the X-ray transient output of IGR J11321-5311. It's a pretty consistent X-ray source, as you can see here on the 15-year chart. And here is the 30-day chart in the lower left. And next we'll go to SIMBAD and see if we can image this at all. Does it show up on Aladdin Light? I see something there. Indeed, the crosshair is in a weird spot considering where the brightness is. And that may be a foreground object. Not exactly sure. Let's see if it shows up on the multi-mirror project. The XMM Newton, not showing up there. Let's check the Chandra. Nothing on the Chandra. Let's check infrared. On the 2MASS, one of my favorites. And it must be that source right there. Not exactly sure why the crosshair is at the bottom of that. It does indeed appear to be that bright source. So, again, that's today's featured object, J11321-5311, another catchy name for this X-ray source. And you can look this up yourself at the Neil Gorell Swift Bat X-ray Observatory if you like. And let's talk cosmic rays. We didn't cover it yesterday, but we would have if the site wasn't down. So here's the Apatity neutron monitor, and look at the wild upturn here at the end of the graph. That is a wild enough upturn right there to turn the whole graph into an uptick over the past 30 days. So big uptick at the Apatity neutron monitor. Cosmic rays are the highest energy particles from space that we're aware of. And there are many, many monitors in the world. We cover certain ones on the regs on the channel in order so that we have sort of an ongoing understanding of specific monitors. So there's Apatity, here's Barentsburg, and we see no such similar uptick there at Barentsburg. Barentsburg much flatter, if not flat entirely, almost entirely flat on the past 30 days at Barentsburg. Next we'll go to a location much farther south, right after I check the life of the stream. And everything looks just fine. Let's go to Athens, Greece, the neutron monitor there. And we're seeing some technical difficulties with the website here. Our reference site has not loaded. There we go. I think it's going to load. A little bit slow today. There were lots of internet outages yesterday all across Europe and so on. Just bear with it. We are streaming live. Here is the Athens neutron monitor. And you can see Athens is pretty flat there over the past 30. Next we'll go to Mexico City, going even farther south. And Mexico City's flat on the past 30 days as well. Lastly, we'll look at Oulu, Finland, and 2 Antarctican monitors. So there's Oulu, and it's actually a similar chart there to Apatity, although not as much of a wild uptick. And that is a slight uptick over the past 30 days there at Oulu, Finland. Here's DOMB Antarctica. Pretty flat over the past 30 days there. And here's DOMC Antarctica. Flat over the past 30 days at DOMC as well. If you want to look these up yourself, don't take our word for it. Do a search for links to cosmic ray data, and you'll find this Russian site. And that's today's cosmology segment. And we cover cosmic rays because cosmic rays are quite important, not only to cosmology, but also to things like climate. Let's get back to some data, and we saw a solar flare happen here as we did the daily space weather. So here you can see a B-class flare happening as we streamed live, certainly happening after we started the live stream. Shout out to the sun once again, and if you've got a comment for the sun, just leave it in the comments. We read all the comments. What you really have to ask yourself is, does the sun read all comments? Now, ancient civilizations all believed that the sun was conscious. Not all, but vast swaths of ancient civilizations believed the sun was conscious. And no more on that. Perhaps we'll make another video about that at a later time. If you've got comments directly for the sun, leave them in the comments section of the video. Perhaps we'll read them at a later time. And I mean read them in the video. So yeah, a B-class flare happening as we stream live. Here's the proton flux over the past 3 days. No spikes in that. We show it daily because it's very important when coronal mass ejections do strike. Next, looking at the real-time solar wind to see pretty homogeneous solar wind here over the past 24. A small uptick recently happened here in the density, but nothing to write home about. Current solar wind density 7.22 protons per cubic centimeter. Current solar wind speed now having dropped below 400 kilometers per second. Here's the KP index, a global measurement of geomagnetism, and the KP index is at 2. And we are expecting this to be at 4, according to the NOAA forecast, and then at 5 first thing tomorrow morning on the 6th. Another minor geomagnetic storm forecasted as a result of an incoming coronal hole wind stream from that North Pole-oriented trans-equatorial coronal hole system. Next, looking at the pressure here, the magnetohydrodynamic pressure in the geospace. It's our geospace magnetosphere movie for the day. It's 4 hours of data. It's generated via the space weather modeling framework. No surprises there as we see a slowly decreasing solar wind speed. Here are ground magnetic perturbations. And you're looking at changes in the Earth's B field here, otherwise known as geospace delta B. Since we're living through a polar excursion right now, we've got 2 north poles, one up here somewhere, one up here somewhere, and the net north pole somewhere over here. That's where your compass would point if you were down here. And the South Pole is someplace over here, someplace south of Australia, well off of the Antarctic continent. It's a feature of a geomagnetic excursion. This is also 4 hours of data like our other magnetosphere movie. And some pulses coming out of the Pacific Ocean there. If you need to rewatch it, just bring it back. It's the beauty of video on demand. Here's the GOES magnetometer over the past 3 days. And we see some pretty spiky sawtooth readings in here. No real surprise there, as there were coronal hole wind streams showing up, and a lot of plasma in between you and the magnet significantly affect the readings on your magnetometer. So let me just repeat that. A lot of plasma, in this case mostly hydrogen nuclei, a lot of plasma between you and the magnet affect your magnetometer readings. And that's why the spacecraft tells you when it turns on its thrusters, which is that arc jet moment there, as its thrusters create plasma, which can affect its magnetometer readings as well. Next, we're looking at the National Sunspot Observatory top view ecliptic plane field plot, which shows you the polarity of the heliospheric current sheet, and the Earth is about to move into the South Pole-oriented current sheet, shown here in red. By tomorrow, I would anticipate us to be in that South Pole current sheet. And it looks like we may see some activity building here. I'm going to actually forecast a sunspot. I think we're going to see a sunspot form somewhere in the eastern limb of the sun. in the next 24 hours. I don't usually do that, but today I will. So we're currently in the North Pole current sheet shown here in green. By tomorrow's daily space weather, we should be in the other current sheet. Which makes me bring up a joke. Why did the Earth's potential field surface source line cross the current sheet? Anybody? Anybody? The answer is to get to the other polarity. All right, that's a nerdy enough joke for you there, I think. Next, looking at the line of sight coronal hole plot, and you can see that green area here around the solar equator. That's the North Pole oriented coronal hole system that will be providing the coronal hole wind stream that we're expecting late today, early tomorrow, and that geomagnetic storm that's forecasted, and some periods of geomagnetic unrest surrounding that. This also shows you the sun's B field in blue. And we've got old data on the solar coronal magnetic field plot, so that's 2 days ago, so there's no point in really showing that. Here is the just a diagram of the Earth's Van Allen belts, as the Earth is surrounded by these two, the inner and outer Van Allen belts. And those contain all kinds of different charged particles, electrons, molecules, as well as hydrogen nuclei, and pretty much everything on the periodic table is in there, but in certain quantities. I won't get into the chemical composition of the Van Allen belts right now. Those particles are largely held in there by bands of relativistic electrons, which are blasting back and forth, especially in the outer regions of these. Keep in mind, distances are in miles on this diagram. Now that we're getting into electricity, here we are at charging hazards. And we see some charging hazards here over Central America, the Central Pacific, the Indian Ocean south of the equator, northern Australia, etc. Those red areas are where we may see satellite charging hazards. Not significant ones particularly here. We don't expect many communication errors, if any. Next, the electron flux. And we've stayed in electron storm levels here, electron warning levels, staying above this red dotted line, which coincides with 1,000 pulse flux units. Our patrons would be well aware of this as we send alerts to our patrons on the regs. So that's a 3-day chart of the GOES electron flux as measured by the GOES 16 at the F ionosphere layer. We'll show you where that is in a moment. Here's a 1-year chart of the electron flux to put it in context. That chart is available at solon.info/solar as well. And here's the forecast model. I would disagree with these green boxes here, at least the first one. I'll point to this one. That green box there, I would expect that to be down a bit lower than what we're seeing. Don't bet the farm on it, though, because we just ended a coronal hole wind stream, which often coincides with higher levels, which is why NOAA failed on its forecast right there. And for you new viewers, the yellow diamonds are the observation, the green squares are the forecast. Here's a visualization of the total air column up to where your GPS satellite may be located all the way down to your handset. We're looking at electron density here, and we see a fairly normal total electron content forecast here. Nothing to write home about. If you need to view that again, just bring the video back. And here's the diagram of the atmosphere. So it's showing you the troposphere here, the layer in which all of your weather occurs and in which you live. It also shows you the penetration of electromagnetic radiation into the atmosphere, up there in the center, temperatures at solar minimum versus solar maximum, and this red F over here on the right, that is the F ionosphere layer where the GOES 16 is around 300 kilometers altitude. Here's a slice of the atmosphere, just the ionosphere, in vibrational frequency. And those blobs those coincide with different frequencies. So these are vibrational frequencies here in megahertz. Ionosphere looking fairly normal here so far. Here's the latest image from 10:15 Universal Time. Next, we'll do some meteorology stuff. Let's do some meteorology. First of all, I would note the jet stream is blowing backwards over the entire Indian Ocean right here. Jet stream blowing east to west in that portion of the world. Also, jet stream doubled up and tripled up here in the southern hemisphere, doubled up and tripled up in the northern hemisphere. So that's the eastern world. Let's rotate the planet to the western world, I think. There are the jet streams of the west. Also some chaotic stuff going up here over northeast Canada. Anyway, the jet stream, which we view in the 250 hectopascal winds, it's a very specific wind band that coincides with the likely location of the jet stream. This is from nullschool.net. If you're wondering, it's nullschool.net. Next, looking at a real-time lightning map. When I hear thunder, I go to lightningmaps.org. Have you forecasted thunder? Have you freaked out your foes and convinced them that you're Thor or perhaps Odin and that you're causing the thunder? Have you convinced people with a bone through their nose that you are a god? Let us know in the comments. Or just use lightningmaps.org. I like it. And it's a pretty low lightning environment right now. Some north of Saudi Arabia there and some off of the west central coast of Africa and a little bit in the Atlantic Ocean as well. Next, looking at pressure cells here. Here are the pressure cells associated with atmospheric pressure on windy.com. Here's where the GFS forecast puts them tomorrow at, that's 1 p.m. Eastern time right there. I would note the entire southern geographic polar region is entirely dominated by low pressure. And again, there's where we expect pressure to be, according to the GFS forecast, at 1 p.m. tomorrow. Next, looking at the cloud layer here, using the NASA GOES Interactive Weather Satellite's shortwave radiation map. It's 3.9 nanometers. And check out the low clouds over the North Atlantic here. Massive amount of low clouds in this area under my pointer. And really one group of clouds here. A weak low pressure system there over Oklahoma. You can see a tiny bit of counterclockwise rotation in that area, indicating a low pressure system. Low pressure systems rotate counterclockwise in the northern hemisphere and clockwise in the southern. Here is the water vapor map. And you can see that dry mass of air colliding in with that moisture. Great view of that. Next, the U.S. Doppler radar map. And let me just check the life of the stream again, because, again, we are streaming live. We like the live format, folks. Here's a U.S. Doppler radar map. And then we've got some snow once again in southern Colorado. Hey, Smash team. Thanks for tuning into the video. The most important members of the Smash team are our patrons. We've updated our Patreon credit crawl. Please consider becoming a patron. It helps us out a lot at patreon.com/smashamash, the true source of funding for the content. Again, it's patreon.com/smashamash. And thanks again to our patrons. Thanks for opening your non-cobweb encrusted wallets. And if you refuse to open your cobweb encrusted wallet, just press like and subscribe on YouTube so the place doesn't burn to the ground. Press the share button, press the notification bell. Tell your friends and foes and your science noobs and your science pros about the content. Lots of interesting things coming for the channel. No more on that in today's video. We've got bonus features. an analysis of sunspots 2806 and 2807. So here's the solar intensity gram. And those sunspots are looking weak. They're barely in existence anymore. There's 2806, which may lose its name today. I would say it probably will. Here's 2807, still barely a beta class sunspot there. Here are the magnetic fields. Here's 2806. And here's 2807. Do we see any magnetic organization over here on the east side of the sun? One little area right there. And I wouldn't be surprised to see that turn into a sunspot. Let us know if anybody out there is forecasting coronal mass ejections or sunspots before they're existent. We'd be more than interested in that. Although pretty sure that is not the case. So let's do some close-ups of the southern hemisphere. First, the 171 angstroms full disk view. And you can see that bright spot in the upper left there. The only area, besides those sunspots, of significant magnetic organization. It is building a little bit here. Here's the southern hemisphere in 304 angstroms ionized helium. Great view of those in close-up mode. Here's 171 angstroms, which is iron 9, I believe it is the ionization state of that very hot gaseous iron. Here's 193 angstroms. And I think that's our last video, folks. It's about time to close this thing out. Thanks again for tuning in, everybody. Interesting filament down here as well. Thanks again for tuning in, everybody. Remember, stare at the sun, attempt to understand the physics, and when you're staring at the sun, don't drink. But if you do, don't drive. Welcome to the Neo Renaissance. Visit our links and support the channel, please. And since it'll never be now again, may that solar wind be at your back.